Here's another illustration of periodic selection, here with some emphasis on the decline of those alleles that in fact are not found in the selected genotype. So once again, we have a little a and a big A allele making up a genotype that is in a minority within this population. And here we have a mutation from the little a allele to the big A allele. The result is that the big A allele in this case is actually displays a selective benefit and drives this genotype towards fixation up here. But in the process of all of this, what's going on with the other genotypes and alleles within the population? Well, the answer is that although the little a allele apparently was found across the population initially, the big B allele was not. And when we had the mutation from little a allele to big A allele and suddenly had a genotype that had a selective benefit relative to the rest of the population, this selective benefit not only resulted in the increase in the big A allele and therefore a decline in the little a allele, but also an increase in the big B allele and a decline in the little b allele. Thus, the flip side of fixation in the course of periodic selection is in fact the purging of the population of genetic variation. Now, down here it's kind of ambiguous what exactly happens to these guys. Have they been purged to the point of zero? Have they been purged close to zero in terms of their frequency? It's not entirely clear. But what is clear is that we see this dramatic decline in the frequency of both the little a and the big B, little a and little b allele as a consequence of the periodic selection and ultimately fixation of the big A allele and the big B allele.